So in this video, I'm going to discuss case 3 of partial fractions. Case 3 is when the factors of Q of X are linear and quadratic. So it's a combination of linear and quadratic. And none of the quadratic factors is repeated. So actually, our main focus at case 3 is on the quadratic factor because for linear factors, we already have discussed it cases 1 and 2. Okay. So for case 3, it's on the quadratic factor. And make sure that no quadratic factor is repeated. So corresponding to the quadratic factor example, you have this quadratic factor x squared plus bx plus q in the denominator is the partial fraction of the form. So pag-convert we have this partial fraction. So remember na for linear factors, we only have constants sa numerator like a or b or c. But for a quadratic factor, this is what is written sa numerator. Constant times x plus another constant. Okay. Mao ni ang substitution or equivalent sa or partial fraction that will be used. So to illustrate, let's have this one. Evaluate the integral of x squared minus 2x minus 3 all over x minus 1 times x squared plus 2x plus 2. X minus 1 is a linear factor. But x squared plus 2x plus 2 is a quadratic factor. And we cannot factor this one. Okay. We cannot break this one into two linear factors. So, our partial fraction is this. For the linear factor, we only have a constant, a over x minus 1. But for the quadratic factor, we have this bx plus c. Okay. So same with the previous two cases, we are going to get rid of the denominator. So we will multiply the equation by q of x, this one. Multiply na to. And then distribute. This is the result. X squared minus 2x minus 3 equal to a. So, again, optionin mo what to use in solving for the constant. Either mag-substitute kag x. In this case, we can only use x equal to 1 para ma-zero ang b and c. So we can solve for a. But for b and c, we have to substitute two values of x in order to solve for b and c. But if you want to compare coefficients, in this case, mas simple ang coefficients, pwede ra. So you solve for the constants, you distribute ang ax squared plus 2ax plus 2a, bx times x, bx squared, bx times negative 1, negative bx, c times x, you have cx, c times negative 1, negative c. And then compare the coefficients. The highest power is 2. So we'll start with x squared. So for x squared, sa left side, we have 1. Ang coefficient sa right side, we have a and b. For x, we have negative 2 sa left. Sa right, we have 2a minus b plus c. And then the last one is constant. Sa left, we have negative 3. Sa right, we have 2a minus c. So using your calculator, 3 equations with 3 unknowns. Then we have a equal to negative 4/5. B 9 over 5, C 7 over 5. Okay, so we're going to substitute the values of A, B, and C sa partial fractions. And so we have this. It's identically equal ng tulo ka lines. So the integral of this P of x over Q of x is equal to negative 4/5 dx over x minus 1 plus 9 over 5 x dx over this plus 7 over 5 dx over this one. For the first term, this is simply ln of x minus 1. But for the second term, if this is our u, x squared plus 2x plus 2. Okay. Let theta x squared plus 2x plus 2. Our du is 2x plus 2 dx. Or if you factor out 2, it's x plus 1 dx. Ang problema is we only have x numerator. So how are we going to simplify this one, the second term, so that we will have this one, x plus 1 sa numerator. So let's modify this. So from x, we can modify it to x plus 1 minus 1. The purpose is so that we will have the x plus 1. Anyway, x plus 1 minus 1 is simply x. So like this. X plus 1 minus 1. And separate nato we will separate x plus 1 from minus 1. Okay, like this. So x plus 1 separated minus 1 times 9 over 5, we have this. Okay. So, pag mag-integrate niya, if this is our u, x squared plus 2x plus 2, we have du x plus 1 dx. Okay na. Diba? So, we already have solved the second term. The next problem is the third term. The third and the fourth term can be combined. You have minus 9 over 5 plus 7 over 5. It will just result to negative 2/5. But our problem is the denominator. Now, so sa denominator, okay, na x squared plus 2x plus 2, how are we going to simplify this or modify this one? With x squared, always think of completing the square, or making it either sum of two squares or difference of two squares, so that you can make use of inverse functions or you can use trigonometric substitution. Okay. So, see, let's simplify. Okay. Let's substitute 9 over 5 from the previous steps. X plus 1 dx is simply du over 2 over u. And, okay. This one, x squared plus 2x plus 2 is is modified as this. X squared plus 2x plus 1 plus 1. Oh. And this one is a perfect square man. X plus 1 squared man. So, the next step is this. 9 over 5 times 1 half is 9 over 10. ln of u, okay, du over u man. Integral of du over u, ln of u. And this is our u, x squared plus 2x minus 2. Now for this one, if you can still remember inverse function, this is arctan. Arctangent by u squared plus a squared. Okay, so this is arctan of u over a. But our a is 1, so it's simply arctan of u over 1. Okay, this is a standard form sa inverse trigonometric functions. Now, for case 3, we also have an alternate solution in solving for the constants. Now, okay, let's recall. This is the partial fractions. X minus 1 is linear, x minus 1. So, on the numerator, we only have a constant a. But for quadratic factor, we have bx plus c. Now, the technique for this alternate solution is, instead of x, we are going to replace it by the derivative of the denominator. The derivative of x squared plus 2x plus 2 is 2x plus 2. So what we are going to do is to replace x by its derivative, by the derivative of the denominator, like this one. Replace x by 2x plus 2. This is our modification. So that we can save some steps now instead of the previous solution. Okay, so after this, same lang, multiply the whole equation by q of x. Multiply, and then this is the result. X squared minus 2x minus 3, a times this one, and then b times 2x plus 2 plus c times x minus 1. And then you expand, this distribute. Okay, distributor. Okay, this is the result. Ax squared plus 2ax plus 2a, 2bx plus x times x is 2bx squared. 2bx times negative 1, negative 2bx. 2bx times x, positive 2bx. 2b times x rather is 2bx. 2b times negative 1, we have negative 2b. C times x, cx, c times negative 1, it's negative c. So next is mag-cancel, no? Mag-cancel ando. And then compare. Compare coefficients for x squared. We have 1 sa left. Sa right, we have a and 2b. For x, you have negative 2. Sa right, you have 2a plus c. And then for constant, we have negative 3. Sa right side, we have 2a minus 2b minus c. And 3 equations with 3 unknowns. Solve for a, b, and c. And this is the result. This is our a, negative 4/5 over x minus 1. B, 2x plus 2 plus c. Okay. So, therefore, the integral of x squared minus 2x minus 3 dx all over x minus 1 times x squared plus 2x plus 2 is equal to this. Negative 4/5 dx over x minus 1. Let's separate, see? So plus 9 over 10 times 2x plus 2 dx over x squared plus 2x plus 2 minus 2/5 dx over x squared plus 2x plus 2. Now, take note, if this is our u, x squared plus 2x plus 2, then our du is 2x plus 2 times dx. So therefore, du siya, du over u, that's ln of u. ln of x squared plus 2x plus 2. Sa first term, it's ln of x minus 1. Sa third term, this will result to natong arctan. We'll modify it into x squared plus 2x plus 1, open and close parenthesis niya plus 1. So if you will check this one sa previous na solution, same lang. Take note, oh. The first term, negative 4/5 ln of x minus 1, which is correct. Sa second term, 9/10 ln of this. 9/10 ln of u. Okay, u siya, our du is 2x plus 2 dx man. So du over u ln of u. And the third term, this one, negative 2/5 arctan. You'll get the same result. Okay. So it depends on you whether you will just use bx plus c, or you can replace x by the derivative of the denominator. Choice nimo. Okay. So that is for case number 3.